We were inspired by Japanese vending machines when we saw they had cool products such as ramen noodles and popcorn available in a self-serve kiosk. In the US, we mainly only see pop machines and chips and snacks. And we thought that we could try to utilize our EET curriculum and senior design project to actually create a ramen noodle vending machine similar to that of Japan. Obviously, because of the cost and time constraint, we were not going to actually build a full-size vending machine, so we decided to minimize the scope down to the cooking mechanism to keep it automated. Our scope was to design the cooking mechanism based on a 3D printing platform. We were then going to actually store the noodles inside of flavor pods. Now, the reason we decided to do pods is because we did not want to use the hard noodles and we wanted a faster cook time. So we decided to use fresh noodles but needed a way to store them. Now, we found this edible product that was actually dissolvable in water. So we were going to try to make little pockets that would actually hold the ramen noodles and then utilize the linear movements of a 3D printer to actually control the cooking mechanism. Our goal for the pods was to be able to actually make a small little pocket that would actually hold our serving of noodles. Now, the noodles were going to be by themselves and separate from the flavoring. We were going to add that in a later step. We wanted to be able to stage a cup and the noodles in order to actually try to quicken the process. Now, the pod material needed to be able to dissolve in hot water and then be safe to actually eat. We actually found a video telling us how to do that, and I tried that several times, but unfortunately it kept cracking or absorbing into the pan, and I could never actually get the film to actually be able to fold it into like an envelope and then seal it with our pods. Now, I did end up finding a company called Monosol, and they actually make a food grade material that is safe to eat, and they do sell it, but unfortunately when I reached out, I guess they only partner with actual like companies, and since we were only a school project and not really marketing it, they unfortunately turned us down and would not offer any sort of like free samples or sponsorship. Now they did at least try to offer me like a product on Amazon that was actually dissolvable but not edible. Now, we were going to actually do that as a proof of concept, but unfortunately that was around the time that the outbreak was happening. And we found out that Amazon was actually trying to limit a lot of their shipping items to the essentials, and we didn't want to risk missing out on those items just because we had a short time to actually get these videos out. Hello, my name is Jonathan Nguyen, and I was in charge of the mechanical design of the Auto Ramen team. I ended up choosing a aluminum-based frame because these are actually really common when making a 3D printer. Now again, we kind of chose a 3D printer because we were just trying to utilize basic movements and linear motion to actually do a lot of the cooking. So we just needed an ability to have a bed that would slide back, and then have a carriage that would slide left to right, and then a Z that would go up and down. Now, the bed is actually the thing that would actually be holding the cup, and that would be pulling it to 3 different stages. It would initialize an empty cup holding just the noodle by itself inside of the pod. And then it would actually get pulled back, and then that would enter the cooking stage. Now, the cooking stage needed to utilize a side-to-side motion because we were going to actually have it slide based on the order from the customer. We were going to offer chicken and beef. Now, we were going to have nozzles on each side of the main carriage, and that was actually going to drop bouillon cubes into the mixture. And then actually when the carriage slid back to center, that was actually going to pour the water in and do a mixing motion. And because of that mixing motion, we needed a carriage to slide up and down to actually put the spindle in because we wanted flavor to be mixed thoroughly. So again, we chose this aluminum, and then we actually utilized the new 1819 building to 3D print a lot of the brackets, and then a lot of the other main things to hold like limit switches. We also actually, because the plastic is just like PLA. So we also wanted to reinforce it with like some aluminum 90-degree angle brackets. And again, the way that aluminum works is it actually has like a T-nut. So when you tighten it and that turns, it actually grips onto the aluminum. That was actually really nice to work with, was really easy. We just kept having to 3D print brackets week by week, day by day, and slowly we just built the overall machine. We 3D printed things like switch holders, we had belt tensioners, we had all these different brackets that actually stiffen up the mechanical chassis because we do have some vibration with a lot of the movements. A lot of the movements are also then controlled through stepper motors. Again, these are really common with 3D printers, so we just needed them to be a little accurate, but a lot of our accuracy came from the upper limits and lower limits controlled by limit switches. Grayson will actually end up going through all that in the programming section.
Hi, my name is Grayson Farrell. I did the wiring and programming for the Auto Ramen Vending machine. Our first choice as a group that we had to make was whether we wanted to use a PLC or an Arduino to run our machine. The choice kind of was simple. We had to go with the Arduino Uno. That choice was made because the Arduino actually connects to the CNC shield. So let me show you that real quick. So when this thing gets connected, Uh, all the stepper motors can be run off these four points of interest. Each point has 4 pins that ties right into the stepper motor. So we were able to control at most 4 stepper motors. So A right here was jumpered with these two things. A was jumpered because it's meant to be a mirror off of one of the 3 other points of interest. So instead of mirroring it, we wanted it to run separately so we could run an x-axis, a y-axis, a z-axis, and an A. The A would be our blender, so that would just be a circular motion, and we just thought a stepper motor would work out very well for that. So that's in principle how the CNC shield worked. It worked out really well, but this was my first time programming it, so there was a couple of issues. The first issue was, as you saw me put it together, there's no inputs. So we had to figure out inputs. If you look right here, you can see cool enable and abort. Those 2 pins we found were actually being able to manipulate into it being inputs. So we could decide what flavor we'd want. If it was beef or chicken, we could click one button and our x-axis would be able to shift left or right and pick a seasoning. And that actually ended up working out really well. Another important part of the CNC shield are these end stops right here. Now the end stops, you can see there's an X plus, a Y plus, and a Z plus. We tied those to our limit switches so that we could make sure our access didn't go further than we would want, and everything would operate as we'd expect. So if it went one direction, it would go all the way, hit the limit switch, and then the second step would then be activated based on that limit switch. Um, and that actually worked out very well. Not a lot of issues came from that. Um, as far as the code goes for this project, it was relatively simple because we did do it in Arduino Sketch. And the problem with Arduino Sketch is that it is a very easy uh, way to code, and we wanted to demonstrate that we could do more. So the plan was to keep this in Sketch because it worked, and we wanted it to stay the way it was. Don't mess with something that's not broken. But then we would use this Arduino and we would set this up in C++, and we would end up connecting our water solenoid, our temperature sensor, pretty much all the cooking process in this, not the moving of the axes or anything like that, but the cooking would be run off C++ with this shield or with this Arduino. Unfortunately, due to the pandemic that has hit, uh, we really can't be working together anymore. So this idea kind of got diminished. We really can't demonstrate the C++ code anymore because even though I can write it, I can't implement it and see if it actually worked. So that's unfortunate, and it really just sucks. But the plan was actually pretty well thought out. We were already making steps to test our temperature sensors, and we were already taking steps to work on the water pump. And all these ideas were about to be done, and then we just couldn't continue on anymore. The good news is we got relatively far in our project. Like I said before, the shield worked, the axes all moved when we planned on it, how we planned on it. Um, Another issue, I guess not really an issue, but more of a topic of conversation is in the code there are spacings of delays, which we had planned on implementing with the other Arduino to do the cooking in those delays. The delays would have been longer and timed out based on how long it would have taken to cook. But unfortunately, like I said, none of this can be implemented, but it was the thought that our group was taking. Thank you.
Hello everyone, this is Sumala Kafando. I'm a part of Team 5, and our project was intended to build a ramen vending machine. So I'm not going to talk about the scope of the entire project because I know John already talked about that in the introduction. So I'm going to just focus on my part on what I did for this project. So for this senior project, I worked on three different parts. The first part was the heating system. The second part was the machine wiring. And then the third part and the last one was the troubleshooting. So for the heating system, we had to figure out and find a way how we can get the hot water into the machine to be able to cook the noodles. So for that, we had the idea to use the Keurig coffee machine. If you go to our PowerPoint presentation on slide 11, you will see the coffee machine that we use for this part. And what I did for this part was to break down the entire coffee machine and took out the eating system of the machine and try to understand it very well and see how we can use that on our in our project to be able to get the hot water and then get the noodle cook very well. So after that, after the I mean, the mechanical work and the programming work all done. So I had to take the project and then wire the entire machine. So after that, the machine, like every other project, so there will be some problems, and the machine was not our ramen vending machine was not working properly. It was not working the way we wanted to work, and this is when I had to troubleshoot it. So we had to check the entire wiring and figure out what what's the problem, what the problem is, what causes the problem, then try to fix the problem and then verify that the issue has been fixed and corrected. So we had to also follow up to make sure that the issue is fixed and then will not happen in the future anymore. And after the troubleshooting, the machine really started working smoothly, and probably you will see a video that will be attached to that one, and you will see how the machine is really working very well. So thank you so much, and thank you for your time, and bye.
The following video was used to test the linear motion, limit switches, and mixer control. The spindle is too long and was going to be cut down for the final prototype. This was just a functionality test for those components. First, the bed will be pulled back into the cooking position. Then the carriage will slide to the side based on the customer order. The appropriate flavor will then be added to the cup. Next, the carriage will return to the center and lower the mixer into the cup. The mixer will then run for 10 seconds.
Once the mixing is done, the Z-axis will pull the spindle out of the cup, and the bed will move forward to the serving position. Once the order is received, it will then pull back to the restart position.